In this lesson, we are going to look at numerical data in AI Lab. So as you can see, this is lesson 12. By lesson 15, you will be making your own AI app. All right? Your journal prompt for your warm-up is Brianna and Michaela are movie critics who use different systems to recommend movies. Brianna recommends movies as either go see it or don't bother. Michaela recommends movies on a scale from 1 to 10, such as 7.2 or 4.1. How are these two systems similar? How are they different? Pause the video here so you can answer this in your journal. So, Brianna's system is categorical. It's either good or it's bad. Michaela's system is numerical. Both of these systems help us make decisions whether or not we want to go see the movie, but in different ways. Brianna's system looks similar to the type of recommendations we've seen so far because it simplifies the data into two categories. Michaela's system is a little different, using a range of values to make a recommendation. This is numerical data. In this lesson, we will learn how to use numerical data in AI Lab to make new kinds of recommendations and predictions, which brings us to our question of the day. How can we use AI Lab to predict numerical data? Your key vocabulary for today is numerical data. This is data that can be counted or measured. This is not the first time we have seen this word. Okay. If you feel like it is, you need to go back and watch all the previous lessons until you find the one where we talk about it the first time. Okay. So what are other examples of numerical data? So some examples might be your height. Okay. Your grade point average, your GPA, that's numerical. Every grade you get in this class and every other class is numerical. Your age is numerical. The cost of anything is numerical. Any type of rating system, like Michaela's movie rating system, that's numerical. Okay. So we can always tell there's numerical data around us. And in this lesson, we're going to take a look at numerical data in AI Lab and how we can use it to train a model. Let's watch a short video.
Numerical data in AI Lab is a little different from categorical data. Let's take a look at an example where an amusement park wants to use machine learning to predict how much revenue it will make on a particular day. Instead of bar charts, numerical data shows the minimum and maximum values of the data set. It also shows the range, which is the difference between the min and max. Instead of crosstab tables, numerical data shows scatter plots. These graphs still show how two columns are related to each other. The label is always shown along the left-hand side, and the feature is always shown along the bottom. Don't try and focus on each point individually. Instead, try and see if the overall graph has a pattern. For example, in this graph, I can see if there is a low number of online ads. There is also a low number of revenue for that day. And if there is a high number of online ads, there's a high revenue that day. This is a pattern AI bot can use to help make predictions in its model. This graph shows how much revenue is made based on the day of the month. This isn't very helpful for trying to make predictions because of how spread out the data is. It's hard to predict what my revenue will be on a particular day. Another difference between numerical data and categorical data is on the results screen. With categorical data, We could calculate accuracy like a checklist. Every time AI bot guessed exactly right, it made our accuracy higher. With numerical data, it's more like a dartboard. As long as AI bot's guesses are close enough, we still count them as correct. In AI Lab, the difference between the two guesses has to be within 5% of the total range. The actual number changes based on how big or small the data set is, but you can use this details panel to see more information about which guesses AI bot is getting correct and which guesses AI bot is getting incorrect. Training models with numerical data is just like training models with categorical data. You're still helping AI bot find predictions, but the tools we're using are slightly different, and the way we calculate accuracy lets us be close enough.
All right, so we are going to be going with close enough. Go ahead and go to Code Studio, Lesson 12, Level 1, and look at the Safari data. We will actually spend most of this lesson exploring data in the first panel and recording your results on the activity guide, which brings us to what you will need, the Numerical Data in AI Lab Activity Guide in Code Studio. So let's look at what we're going to be doing. If you haven't downloaded the activity guide, pause the video here so you can do that. We have been hired by a Safari company to create a machine learning model to find patterns with how animals behave in the park. The company is specifically interested in predicting how many lions visitors will see. Our job is to create a model that can predict how many lions will be in the park. In AI Lab, click on the antelopes column. All right, we are going to click on the antelope column. Okay, now look at the scatter plot that appears, which compares the number of antelopes with the number of lions. We have the lions on the left, antelope on the right. This is the number of antelopes seen during a visit. You get all of those numbers, and the data type is numerical. Answer the questions on your activity guide. Have you opened your activity guide? If there are a low number of antelopes in the park, what does that mean for how many lions could be in the park? If there are a high number of antelopes in the park, what does that mean about how many lions could be in the park? Why do you think this is? Those are the questions you're going to answer, so go ahead and pause the video here so you can answer them. If you need to look back at the data, go ahead and go back to code.org and look at that, but do pause the video. All right, in AI Lab, click on the People column. People are here. This is the third column. Okay. Look at the scatter plot that appears, which compares the number of people with the number of lions. So this is literally the exact opposite of the antelope. The antelope started down here and went up. That, I believe, is called a direct relationship. And I believe this one is called an inverted relationship. So X is the number of people, Y is the number of lions. If there are 23 people on safari during a visit, there are usually 96 lions. Okay? If there are 200 people on a visit, there are usually 11 lions. So why is it that the more people that come into the park on safari during a visit, the less number of lions there are? And I am saying lions and not lines. Okay, I know they sound the same because when you get a lazy I, instead of I. All right. So, answer these questions in your activity guide. If there are a low number of people in the park, what does that mean for how many lions could be in the park? Why do you think this relationship exists? Are lions afraid of people? Okay, let's click on the day of the month column in AI Lab. This is column 4. This is column 4. Holy moly, I see no relationship whatsoever. I don't even know what to think about this. Look at the scatter plot that appears, which compares the day of the month with the number of lions. Answer the questions on your activity guide. Those questions are: what happens if you visit on an early day of the month? How many lions do you think you'll see? Okay. Early day of the month. On the 1st. You can see anywhere between 15 and 87. And you get a similar range every single day. What happens if you visit on a late day in the month? How many lions do you think you'll see? It's the same as if you visit on an early day of the month. All right, in AI Lab, click on the temperature column. So, what can we safely say about the day of the month? It does not matter. The day of the month is irrelevant. At this moment, we see no direct relationship between the number of lions in the park and the day of the month. Okay. We said we're clicking on what? Temperature. Oh, look at that curve. It's a scatter plot, but it's a bell curve. Very interesting. Okay. Answer the questions on the activity guide. Those are: if there's a low temperature, what does that mean for how many lions could be in the park? Low temperature, low number of lions. High temperature, low number of lions. Decent temperature, high number of lions. Okay, why do you think this is? This is, it could be me. Okay, high temperature, no me. Very low temperature, probably not me. Nice temperature, me. Okay. Which graph would not make a good feature? And I already said this. This one right here. Why? Because there's no direct relationship. Okay, this is a direct relationship. This is an inverse relationship. So direct means as one goes up, the other goes up. Inverse is another form of the word inverted. And that means when one goes up, the other goes down. And then a bell curve is your standard relationship in statistics or something like that. I don't really remember. I'm kind of surprised that I even recognized that that was a bell curve. Okay. So, we can use AI Lab to train a machine learning model to predict how many lions we'll see when visiting the park. We want to make sure we can use features that have a relationship with our lions. Based on the ones we've seen so far, we know that the day of the month has no relationship with our lions and would not make a good feature. Okay? So I kind of feel like numerical data might be easier to determine a good AI model versus categorical data. Okay, so let's go ahead and train a model using these investigations. Okay, continue to explore the data by clicking on the remaining features in the data set. Record your observations on your activity guide. And using these investigations, train a machine learning model that is at least 80% accurate. So we're going to be over here. Train a model that is 80% accurate. Okay, I would not use this. This one looks really bad. Relationship info, hot mess. Okay, no relationship. Mosquitoes. Number of mosquitoes seen during a visit. When there's a lot of lions, (52x). Okay, when there's a lot of lions, there's not a lot of mosquitoes. That's kind of odd, because I really don't think mosquitoes would be afraid of lions. What is the relationship between that? When there's a low number of lions, there's a lot of mosquitoes. Okay, so you are going to look at all of the data. Choose the features. Remember that all of the features don't make it more accurate. So don't choose all of the features. If you add day of the month and elephant, there is absolutely, those are not going to make it a more accurate model. Okay, so try to keep it under 5 features. All right, and then try to get it with 80% accuracy or better. The higher the accuracy, the better. And you're going to answer these questions. What is another column you think would be a good feature for this model? What is another column you think would be a bad feature for this model? All right. You may struggle a little bit to find a model that is 80% accurate. So you're just going to have to experiment a lot and see which features will help you achieve your goal. And one thing that I do want you to think about, no, never mind. Okay. Pause it. Once you finish training, pause it until you get done training your model, okay? On level 2, once you finish training your model, you can import it into App Lab and begin customizing your app. You won't have enough time to truly finish your app, but the next lesson focuses more on App Lab, where you'll be able to customize your app more completely. Okay, so pause it until you can finish training and then go on to level 2. And once you get done with level 2, we are going to do our wrap-up journal. So in your journal, what is one way categorical data and numerical data are similar? What is one way they are different? And then for your question of the day, how can we use AI Lab to predict numerical data? And that's it for this one.